Hey everybody, this lesson is on sigma formulas. And this is sort of a strange lesson because it's a total review from pre-calculus, but I need to review this in detail because in order for me to do my next lesson, I need you to understand and remember these sigma formulas. So there's no homework to go with this lesson. This is more just take down these notes, keep them with you, so that moving forward into our next lessons in Chapter 5, you know what you're doing when it comes to sigma. So sigma is the Greek letter S, which you're going to see right here. You probably remember seeing this symbol before. And it means in mathematics to sum up. It stands for summation. So whenever you see this Greek S, sigma, you're going to be adding things together. So the first formula, we're going to call this formula number 1. I just straight up need you to memorize this. So this is what it says. The sum from I equals 1 to n of the function I is equal to n times n plus 1 all over 2. So I need you to memorize this. You're going to see why later on down the road. But if I want you to memorize this, I want you to see how it works as well. So if I'm working the left side of this, say I actually pick a number for n. Let's just do the sum from I equals 1. I'm just going to choose 4, so it's kind of going to be a shorter problem. From I equals 1 to 4 of I. So what this wants me to do, it wants me to start by plugging 1 in for this I. So if I let I be 1, then I is 1. Summation means add, so I'm going to add. And now I'm going to let I be 2. I'm going to increase to the next integer. Well, if I is 2, then this becomes a 2. Plus, I'm going to let I be 3. And finally, once I get to the top here, I'm going to stop when I is 4. So the sum of the function I from I equals 1 to 4 is going to be 1 plus 2 plus 3 plus 4, so that's going to be 10. So that's one way to work that problem. What this formula is showing me is that the shortcut to that, if you have this memorized, is to just plug your n, which is the top, in for these n's over here. So in the case of the sum from I equals 1 to 4 of I, my n is 4. So I'm going to replace both this n and this n with the number 4. So it'll look like this. 4 times 4 plus 1 all over 2, which is 4 times 5 all over 2, which is 20 divided by 2, or 10. So either way you do it, you're getting the same answer. So that's how it works. Now, where this formula actually came from is something you would have derived and proven in pre-calculus. So I'm not going to go back over that. I don't need that piece of the puzzle to do my next lesson, but I do need you to know that this is equal to this. Okay, so that's the first formula. Formula number 2. The second formula I need you to memorize is this one. The sum from I equals 1 to n of I squared. This can be replaced with the right side. N times the quantity n plus 1 times the quantity 2n plus 1, all divided by 6. So let's see how this works, or how it's giving us the same answer. So let's use that 4 again as our n. Sum from I equals 1 to 4 of I squared. Okay, so starting with I equals 1, we would plug it in, we would have 1 squared, plus. Then let I be 2. Put 2 in for I, you've got 2 squared. Let I be 3. 3 squared, and then stop your summation when you get to the top, 4 squared. So that's 1 plus 4 plus 9 plus 16. So let's see, that's going to be 5 plus 9 is 14 plus 16 should give us a grand total of 30. Now let's see if working the right side does the same thing. On the right, we're going to replace all of these n's, this one, and yet this third one, with 4, because our n over here is 4. So it will look like this. 4 times 4 plus 1 times 2 times 4 plus 1 all over 6. Now hopefully this is going to give me 30. Let's see if it does. I'd have 4 times 5 times 9 divided by 6. So 4 times 5 is 20. 20 times 9, 180. 180 divided by 6 is also 30. So you can see why I'm asking you to memorize that. There are going to be problems coming down the pike where we're going to have something that looks like this, and to get rid of the sigma and the I squared, we're going to replace it with what we've memorized its counterpart to be, which is why I need you to memorize formula number 2. Okay, on to formula number 3. Formula number 3 is for I to the 3rd power. Okay, so this formula says the sum from I equals 1 to n of the function I cubed is equal to this right side.
Jesse Shalala, please report to Mrs. Young in the attendance office. Jesse Shalala, please report to Mrs. Young in the attendance office.
Okay, sorry about that. So this right side actually mimics formula number 1. It's the same, n times n plus 1 all over 2, but then we're going to take that entire quantity and square it. So just to show you how this one works, let's use that 4 again for n. So I equals 1 to 4 of I cubed. So we would start with I equals 1, so that would be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. And if I do all this, I would have 1 plus 8 plus 27 plus 64. And it's the end of the day, so just so I don't mess this up, I'm going to type this into my calculator. Let's see, I have 9 plus 27 plus 64. I'm getting 100. Okay, so this is this part of it. Now let's work the right side. Again, my n is 4, so I'm going to do big bracket, 4 times 4 plus 1 divided by 2 squared. So 4 times 5 is 20. 20 divided by 2 is 10 squared. And there we have our 100. So these match up as well. So I think you're getting the gist of this. So the bottom line is, the proofs of these I'm not doing, although they do exist. Hopefully you've seen those in pre-calc. When you were doing your arithmetic sequences and series and your geometric sequences and series. But for now, for my lessons, I just need you to memorize these 3 formulas. Okay, last but not least for this mini lesson on sigma, there are 3 other helpful rules I need you to memorize. And again, I'm going to show you how these rules work by example. The first is, if you have a sum from I equals 1 to n of a constant, so this c right here, we should note that c is a constant. You can actually replace this whole side by just multiplying n times c. Let me show you how that works. So let's use that 4 again. So say we're summing up I equals 1 to 4 of the constant. Let's pick the constant 7. Okay? So if we try to plug 1 in for I, there is no I. There's no variable. It's just a constant. So if you plug 1 in for I, you're still going to have 7. Plus, if you plug 2 in for I, well, there's nowhere to go with it, so it's just 7. 3 in, 7, and finish at the top, 7. Well, 7 plus 7 plus 7 plus 7 is 28. That's one way to do this problem, this side of it. But if you don't want to mess with sigma, and you just want the short answer of it, just take n times c. So if you had taken 4 times 7, you would have gotten to 28 much faster. So again, when you're summing up, I equals 1 to n is a constant, and this is a constant, multiply them together to get your summation. Okay? Second to last rule looks like this. It says that if you have a summation from I equals 1 to n of one function involving an I, we'll call this a sub I, plus or minus another function involving an I, b sub I, then you may separate the two into the sum from I equals 1 to n of a sub I, plus or minus the sum from I equals 1 to n of b sub I. I won't show both of these. I'll just do the plus. The minus works the same way, but say you had something like this. Sum from I equals 1 to 4. I keep using that same value because it's consistent. Say you had something like 2i squared plus 5i. So So you can see how this mimics A sub I here and B sub I here. One way to evaluate it is just leave it together. Leave it as 1. So working down this left side, let's let I be 1. So we would have 2 times 1 squared plus 5 times 1 plus, just going to kind of work vertically here, then I would let I be 2. 2 times 2 squared plus 5 times 2 plus, then I would let I be 3. 2 times 3 squared plus 5 times 3, and finally 2 times 4 squared plus 5 times 4. So if I evaluate all of these and then make a grand total, let's see what I'm going to get. This is going to give me 2 plus 5, that's 7. Here we have 8 plus 10, that's 18. Here we have 18 plus 15, that's 33. And here we have 32 plus 20, so 52. So adding straight down, we have 15, 18, 20. Carry the 2, 2, 3, 6, 11. So grand total left side 110. Now, if this formula here is true, then we should also be able to break this problem down by separating these two parts. So this side would look like this. The sum from I equals 1 to 4 of your first part, 2I squared, plus the sum from I equals 1 to 4 of 5I. So you would just kind of be working these down here separately. So if we're just doing the 2I squared, we would have 2 times 1 squared, 2 times 2 squared, 2 times 3 squared, and 2 times 4 squared, and we would add those together. So that would give me 2 here, 8, 18, and 32, giving me a grand total of, let's see, that's 10, 18, 20, carry the 2, 60. Now these don't match, and they shouldn't, because I still have this second part, plus, now if I do the 5I separately, I would have 5 times 1, 5 times 2, 5 times 3, 5 times 4. Add these up. This would give me 5, 10, 15, and 20. So that's going to give me 50 when I add those all together. And now, when I add these, I get that 110. So again, it's just showing you that whether you write the summation together or separately, you're going to get the same result of 110 in the end. And the minus works the same way. Okay, last but not least is this formula right here, pretty simple. This formula just states that if you have a sum from I equals 1 to n of a constant times a sub I, you are allowed to rewrite this with the constant pulled out to the front times the summation from I equals 1 to n of a sub I. So an example of that might look like this. Say we were summing I equals 1 to 4 of 5I. Okay, well if you just leave it like it is, let's see, you would have 5 times 1 plus 5 times 2 plus 5 times 3 plus 5 times 4. So that would be 5 and 10 and 15 and 20, which is going to be 50. So that's your answer if you do it just leaving the constant inside. Now, if you do this way and you pull this 5 out, it would look like this. Originally, you would have the 5 inside, but knowing the rule, you would pull the 5 out and then just sum from I equals 1 to 4 of I. So this would be 5 times, and then you would just do this part. So you would let I be 1, and then 2, and then 3, and then 4. And you can see that's going to give you 5 times 3, 6, 10, which is also going to give you 50. So you're getting the same answer no matter which side you're using. So if you could memorize these basically 6 sigma formulas. Let's just go back over them one last time. Formula number 1 in blue. Don't worry about the orange, just memorize the blue. Formula number 2, memorize the blue. Formula number 3, just memorize the blue, and you'll be fine. And then the helpful rules, just remember the blue, and the blue. Make flashcards, have your parents test you, do whatever you need to do, but have these memorized by the next lesson.